Welcome back everyone. In this video, I'll be doing day 7 of the 30 days of machine learning challenge by Kaggle. Yeah, so if you haven't already watched the first six videos, make sure you go watch them on my channel. Once you finish that and manage to catch up and come back to this video. Yeah, so for this video, I'll be going through the 7th lesson in the Python course on Kaggle called Working with External Libraries. I think in this lesson, what we're learning is how to work with external libraries in Python, because especially if you plan on going down into the data science and machine learning path, there's a lot of libraries that a lot of people have built that's specific for those purposes for data science and machine learning. So for example, for data wrangling, we have Pandas. For visualization, we have matplotlib, Seaborn. These are all examples of external libraries. For machine learning, we have Scikit-Learn. So I think for this particular lesson, the reason why we need to go through this is because we need to learn how to import a library, install a library, import the library, and learn how to use it. So without further ado, let's check lesson 7. Beautiful. All right. So in this tutorial, we will learn about imports in Python, get some tips for working with unfamiliar libraries, and dig into operator overloading. I don't know what that is, but I guess we'll find out. So beginning with imports. So far, the past couple of days, we've looked at a lot of functions that are built in to the Python language itself, but sometimes we need very specific tools in order to carry out very specific tasks. And I spoke about early on, if you want to wrangle data, if you want to manipulate data frame, there's a very popular library called Pandas. So we need to learn how to import the library into our Python. All right, so and the way you would do that is literally via the word import and then the name of the library that you want to import. So here we're importing a library called math. So math is a library for all your numerical computation needs. So this is how you import a library. And we can do dir. I'm not sure what it stands for. So dir, what it does is it'll print out all the available functions that's within that library. Yeah, square roots, we have sine, we have gamma, yeah, all these functions that's available. We have log as well, log base 10, and so on and so forth. Yeah, you can check it out. Yeah, so here, what are we doing here? So yeah, so we're printing the value pi, which is in the math library. So the reason why you need to do this is because pi is in math, so you need to specify explicitly where you're getting pi from. So you need to do math.pi, and then we're doing a format. So this is the format method, which we looked at in the previous, I think, the previous video. And we want pi in three decimal places, 4 digits altogether, but 3 decimal places. Beautiful. And then we also have log. So log is, log takes in 2 arguments. The first one is the number that you want to log, and then you also have to specify the base. So here log base 32 is 5, because 2 to the power 5 is 32. Cool. And if you're not sure what the function does or what sort of arguments, what are the restrictions or what are the conditions on the arguments, you can use help function, which we've discussed a lot throughout the past couple of videos. So here we know that log takes in 2 arguments. The first one is the number that you need to specify to take the log of, but also we need to take specify the base. So if you don't specify anything, I think the default is exponential. But if you want something else, you need to explicitly tell the function what to do. All right, cool. So you can also import a library and assign it to something else. So this is what we call, what is it called? There's a word for this. I'm just trying to look for it. This is quite similar to SQL. So SQL, you can also do this. So you can assign a column. You can change the name of the column to something else. You can change a metric to a name that you want. Oh, okay, there we go, alias. Yeah, so if you're not happy with using the original name of the library, you can do this. So instead of calling math every time you need to use the library, you can just call whatever it is that you want. Here we want empty. I think they also spoke, yeah. So here there's a couple of like common conventions. So I spoke about pandas early on. Pandas, normally people shorten it to PD, just PD. Numpy is NP. Yeah, so these are just common convention that you'll typically see when you visit other people's notebook on Kaggle. Most people normally, do this. So this is just like common convention. Seaborn, I believe, was SNS. Scikit-Learn is like SK or something like that. Yeah, I can't remember. Yeah, so rather than, so what this is saying is, rather than having to specify every time you need to use py to write math.py, what you can do is just import all of the functions within that library itself. So the star here represents import everything. So star, I think this is, again, this is the same as SQL. So if we use a star, that means everything. So what this first line is trying to do is from the math library, I want you to import all the functions in there. To avoid math.py, we can import everything and just use py from there. So notice how we don't use math.log as well. We can just use log because Python knows that we're calling the math library specifically. So here are some errors. So I think why this error shows up is because there are some functions that share the same name across multiple libraries. So the problem in this case is that math and numpy modules both have functions called log, and so if you try to do this and you try to import everything, Python will get confused because Python's not sure at which log exactly you're calling, whether it's part of the math module or the numpy module. So in this particular scenario, if you're using modules that are like very similar, it's always good to just specify exactly which one you're going to use to avoid confusion and to avoid like errors like these. Yeah, so submodule is something that's within how do you explain this? So this is the name of the library, and then within the library we have a module, and within a module we can also have a submodule. So after 6 lessons, you're a pro with integers, floats, booleans, lists, strings, and dictionaries. Even if that were true, it doesn't end there. As you work with various libraries for specialized tasks, you'll find that they define their own types, which you'll have to learn to work with. Yes, so depending on what sort of packages or what sort of libraries you work with, you have to get accustomed to how they do things, because certain libraries want their data type to be a certain way. You have to make sure you make sure you pass in your arguments in a certain way. The output is going to be a certain way. Yeah, so it takes some time to I guess get used to it. Sometimes it might be slightly different or completely different to not completely different, slightly different to what you're used to in the normal Python environment when you're working with external libraries. So that's just something to keep in mind to get comfortable and get familiarize yourself with the libraries that you're working with. But in any event, Google is your best friend, or you can use the help function. So 3 tools for understanding strange objects. So like I said, so these are, I think they're suggesting a couple ways. If you're not sure what sort of data type you're working with, what are the conditions for that particular library, here they're suggesting 3 tools here that can help you. The first one is called type. So if you're not sure the data type of a particular variable, you can just pass it into the type function. So here it tells us that roles, this particular variable called roles, is a numpy array. We can also use dir, which we spoke about just then. So dir lists out all the modules within that library. So here we're calculating the average .mean. I don't think there's a built-in function for average in Python. So this is when it becomes quite handy. So if you're working with a numpy array, this is an additional feature that you gain access to. So if you just do .mean, it'll calculate the average of a list. You can also convert an array to a list by using toList. Array is, I can't remember what the specific differences are, but they are quite similar, but also slightly different. So the final tip, like I said, is the help function, which tells you, which sort of gives you an overall idea of what that library does, what that module does. So yeah, so those are your 3 tools at your disposal that you can use. Enter the final, I believe this is the final section of lesson 7 called operator overload, which I don't know what this is, so I'm going to be learning this as I go along with you guys. So here we have a list consisting of 6 elements, and then we're adding 10. So it returns an error because you can't add a number to a list. But if you do rows, which we know is a Numpy array plus 10, this actually works. So you can add, I believe you can plus 10, you can do numerical computation with an array, but not with a list. The designers of lists decided that adding them to numbers wasn't allowed. So yeah, so this is just something that the people who develop the particular method or the particular data type has determined, which goes back to the point that I made from early on, that it's just something that you have to get used to, what the developers had in mind, and get used to the way in which they've created or designed that particular module. So the designers of lists decided adding numbers wasn't allowed. However, the designers of Numpy arrays went a different way, where they allow adding numbers to each element in an array. Here are a few more examples of how Numpy arrays interact unexpectedly with Python operators. Yeah, so you can also do less than or equal to 3, which I don't think you can with a list. With a list, if you want to do something like this, you have to build a for loop. Whereas with a Numpy array, you can just do, yeah, it's as simple as this. And then it'll go through every single element in that array, and it'll check if it's less than or equal to 3. If it is less than or equal to 3, it will return true, otherwise it will return false. Cool. So here we have a 2D array. We're turning this into a Numpy array. We're turning xlist to a Numpy array. Cool. Yeah, so notice how xlist has a comma in between the 2 lists. So this is actually a list of lists, which we looked at in lesson 2 or lesson 3. Let me check. Sorry, not lesson, yeah, 4. Lesson 4 or 5, I can't remember. But yeah, so notice how this one has a comma in between, whereas x, which is a Numpy array, doesn't have a comma in between. This is a Numpy array, and this is a list of lists. So kind of looks the same, but it's different. It's definitely different. So here we want to get the last element of the second row. The way you would do that is 1. So 1 will tell it to access the second row, and then we want the last element of that second row. Yeah, so that's what it's trying to do. Whereas if we try to do the same thing with the lists, it doesn't work that way. Here we have another library called TensorFlow. So I believe TensorFlow is more for machine learning, deep learning. I think deep learning specifically. I don't have much experience using TensorFlow. I'm not sure what this is trying to show here, but I'm sure this is trying to I'm sure they're trying to convey the same message. Yeah, I'm not going to go through this. You can just go through the text in your own time. And then here they talk a bit about like Pandas data frame as well, which behaves in a slightly different way. But I think the main message that you should take away from all of this is when you're working with packages, with external libraries, always make sure you read the documentations carefully. Have the due diligence, have the habit of checking, reading documentation, which is what I do sometimes at work as well when I'm working with libraries I'm not familiar with. Yeah, so I think that's pretty much it for this lesson. Let's now just jump straight into the exercise and yeah, start working on the exercise. All right, so let's look at question 1. After completing the exercises on lists and tuples, Jimmy noticed that according to his this function, the slot machines at the Learn Python casino are actually rigged against the house and are profitable to play in the long run. Starting with $200 in his pocket, Jimmy has played the slots 500 times, recording his new balance in a list after each spin. Okay, he used Python's matplotlib library to make a graph of his balance over time. Okay, cool. So let's just import this. And so this is Jimmy's balance. So on the x-axis is the number of times that he's played the slot machine. and on the y-axis it's his account balance, I believe. So he started off with $200, and so as he progresses, so this is how his balance progress as he plays more and more games, games using the slot machine. As you can see, he's hit a bad luck recently. He wants to tweet this along with some choice emojis, but as it looks now, his followers will probably find it confusing. He asked if you can help him make the following changes. All right, so we have 3 changes here that we're asked to make. The first one is add title, results of 500 slot machines. Yeah, so one thing I noticed, maybe it's just like because I spend so much time at work looking at like graphs or like previous personal projects, always make a habit of labeling when you're doing any visualization. Label your y-axis, label your x-axis, have a title. If you have like multiple things on your graph, have a legend, be specific, yeah, be like diligent with your naming, make sure you're conveying the right message. So these are all like good habits to build, especially like whether you're doing personal projects, whether you're working in the real world. These are just like stuff that you have to pay attention to. All right, cool. So going back to the task that we are asked to do, we need to add a title. We need to make the y-axis starting at 0. I didn't even notice it doesn't start at 0. So yeah, it's starting not at 0. We need to change that. Add the label balance to the y-axis as well. After calling type function, we can see that blah, blah, blah. So these are the 3 methods that we need to use. Use these methods to complete the function prettify graph. All right, cool. So step 1 is already done for us. They've already set the title for us. What we need to do now is just complete steps 2 and 3. So make the y-axis start at 0. So we need to do graph dot set y lim, set y lim to. It says start from 0. I'm not too sure like what to end it with. So I'm just gonna like, so because y lim, you need to specify a starting point and an ending point. So I'm just gonna say, it looks like, I'm just gonna make it like 350 or something. Yeah, I think 350 or 325. I'm just gonna call it 325. So 325, so we want the y-axis to start from the value of 0 to 325. And the third thing that we need to do is we need to add a label called balance to the y-axis. So we need to do graph dot set y label, and we want it to call balance. I think that's pretty much it. So let's just run this. Beautiful. I think that works now. Can you format the numbers? This is a bonus. Can you format the numbers on the y-axis so that they look like dollar amounts rather than just 0? Yeah, so do this in your own time. Yeah, I'm just mindful of the length of the video. So yeah, just do that in your own time. So let me just check if, you don't have to specify the end. Just do bottom equals to 0. Okay. So here we go. They gave the answer here. Yeah. Cool. Let's move on to question 2. This is a very challenging problem. Don't forget that you can receive a hint. We're trying to perform an analysis to determine the best items for winning races on Mario Kart Circuit. Items is a list of all power-up items the racer picked up in that race and finish. All right, so we have 3 keys. So the first key is called name. The second key is called items. The third key is called finish. So this is the name of the player. This is the items that he or she has collected throughout the race. And this is the number, the placement of the race. He wrote a function below to take a list like this and return a dictionary mapping each item to how many times it was picked up by the first place finisher. Okay, so we just want to focus on the people who finish first place. He tried it on a small example list below and it seemed to work correctly. However, when he tried running it on his full data set, the program crashed with a type error. Can you guess why? Trying to code cell below to see the error message. Once you've identified the bug, fix it in the cell below. Yeah, I didn't even notice they use like two eyes here. So this is, if you're, yeah, try your best to not do like something like this, because you'll confuse yourself, because here we have two for loops, right? So if the first for loop, if you're already using I, and if you use I again in that inner for loop, it's gonna confuse Python, because yeah, it wouldn't know which one to use. All right, let's see if we can correct this. If racer finish equals to 1 for item, so instead of using I, we want to change it. If I is not in winner, if item is not in, yeah, so I think all of these should be item. I think this should fix it. All right, so what I'm gonna try my best to summarize what this piece of code is trying to do. So here we have the outermost for loop is looping through all the races. So here we can see we have 4 races here, right? So that's what the outer for loop is trying to do. So it's trying to access all the dictionaries. So for each racer, so racer here is for each racer, and we're accessing, yeah, so this is telling, so we will probably start from like 0. So for the first racer, so we're repeating this whole process. So this whole process for each racer, okay? So for each racer, if that racer has a finish equal to 1, we want to loop through all the items in that particular racer's items list. If that item is not in winner items count, if it doesn't already exist, we want to create it, and then we want to add, we want to plus 1. I think that's pretty much it. Cool. So we've successfully fixed the error. Let's move on to the final question, question number 3. Okay, cool. So we have 2 hands. Return true if hand 1 beats hand 2, false otherwise. So J, Q, and K are all worth 10 points. A can count for 1 or 11. When determining a hand's total, you should try to count aces in the way that maximizes the hand's total without going over 21. So here it would be 11, 1, and 10. Okay. Okay, so I might need some time to think about this. Yeah, so that's the final, yeah, so it says congratulations here, which means this is the final question. Yeah, I'll need some time to think about this. Once I have something, I'll check back with you guys and explain, yeah, what I've done and my logic in creating the function. All right, I'll check back in with you soon. So here we have a helper function called hand total. So this function helps us to calculate the sum, or the total sum of a hand. So it takes in a list, and then it'll access all the elements in that list and spit out a sum. So here we initialize a variable called total, and we initialize it to 0. We also have a additional variable called aces, which counts the number of aces. So the reason why we are creating this variable is because ace can either take the value of 1 or 11, and you want to choose either 1 or 11 such a way that it maximizes the total sum. And in order for us to do that, we need to count how many aces are there in our hand. So if the card is in J, Q, or K, we want to add 10 to the total. Else if the card is A, we want to add 1 to the aces count. Else we just want to add whatever value, whatever the card value is to that total. And so once we've done all of these, once we loop through all of these, we can deal with the aces such that, so by default, ace, we assign ace as a 1, but there could be some scenarios that we might want to upgrade the ace to 11 depending on what the total sum is. So the condition that we're setting here is that if the total is less than, if we add 10 to the existing total, if it's still less than 21, we want to add it, and then just keep going until you exhaust all of the number of aces. So I think that's what the code is trying to do here. But yeah, and then this is pretty straightforward until, so once we created, I think the hard work is all done here. As long as you get this one right, this one should be pretty simple. So here it's just calculating the hand total for the first hand, calculating the hand total for the second hand, and if the first hand is less than or equal to 21, and if the first hand is greater than the second hand, or if the second hand goes bust, which is greater than 21, we want to return true. Yeah, so that's pretty much it. Yeah, so that's a wrap on the Python course, day 1 through day 7, on this 30 days of machine learning challenge by Kaggle. I hope you enjoy. I'm going to start editing and hopefully push out the first week, the videos from the first week as soon as I can. But yeah, subscribe to my channel as I'll keep on posting as I try to catch up and progress through this challenge. Drop a like on this video as well if you appreciate or enjoy my explanation. But yeah, leave your comments down below on what you think I should explain a little bit better. What am I lacking in some ways? More than happy to help you guys out. But yeah, so take care and I'll see you in my next video.